Hello. Today we are going to discuss factoring of polynomials. So think about it first as when you try to factor a real number like 24, you're trying to look for factors which when multiplied together produce 24. So you have 8 times 3, 6 times 4, 12 times 2, and when we say we're looking for the prime factors of 24, we're looking for the set of factors which are all prime. So 8 times 3 can still be factored as 4 times 2 times 3, and 4 can still be factored as 2 times 2 times 2 times 3. Um, when all of the factors are prime, then we say that we have found the prime factors of 24. Now, factoring polynomials is pretty similar in that we are looking for polynomials which, when multiplied together, produce this polynomial. So as an example, if you have 2x cubed minus 6x squared y, we can look at the common factors of these two terms, which would be 2 and x squared. Factoring that out, we get x minus 3y. And we say that these are the factors of our original polynomial, 2x cubed minus 6x squared y. You can check if that is the correct factor if you apply the distributive method, do a product, and you should arrive at the original polynomial. Now, there are different types or ways to factor, and the first way is to factor by grouping. Or rather, the factors of the common factor, which is what we did earlier. You're just looking for common factors between the terms of your polynomial. As another example, if we have 15x squared y squared plus 10xy cubed minus 25xy squared. Again, we look for the common factors of these terms. You start with the numerical coefficients 15, 10, and 25. The common factor is 5. Next, when looking at the exponents, or rather the variables, you have your x squared, x, and x. So you just have to look for the lowest exponent among all of these, and in this case that is just exponent of 1, so 5x. And similarly with the y's, y squared, y cubed, and y squared, the lowest exponent is 2, so the common factor is y squared. And then we divide the common factor 5xy squared from each of the terms. So 15x squared y squared divided by 5xy squared is 3x. The second term is 10xy cubed. Divide that by 5xy squared, you get 2y. And lastly, with the third term, you have minus 5. The x and the y squared are cancelled out. So this is now the factors of our original polynomial. There are also other ways to factor. You can call these as special factors. You look for certain patterns in your polynomial. First of which we call the difference of two squares. As it implies, you need to have a difference of two squares. So let's say x squared minus y squared. The first term is a perfect square, and the second term is a perfect square, and you have a difference, minus. And this is factored as x plus y times x minus y. So as an example, if you have 4x squared minus 9, we notice that the first term is a perfect square, 4 is a perfect square, x squared is a perfect square, as is 9. So all we have to do now is to get the roots of each of these. So the root of 4x squared is 2x. The root of 9 is 3. So you have the product of two binomials. One will be a positive and one is a negative. Again, you can always check if this is correct by applying the FOIL method or your distributive method, and you should arrive at the original polynomial. So in this example, 2x times 2x is 4x squared. 2x and minus 3 is minus 6x. 3 and 2x is plus 6x. And 3 and minus 3 is minus 9. And you have, after cancelling the minus 6x and the plus 6x, you get 4x squared minus 9. Another example, if we have 36y to the 6th minus x to the 4th. So the first term is a perfect square, 36 is a perfect square. And note that for exponents, for this to be a perfect square, that just means that the exponent has to be even. So y to the 6th is a perfect square. And again, x to the 4th is a perfect square. So the root of 36y to the 6th will be 6y cubed. Note that for exponents, to get the root, you just divide by 2. 6y cubed. And the root of x to the 4th is x squared. And you have a plus and minus 9 here. Okay. Another way to factor is what we call as the sum or the difference of two cubes. So this time you have x cubed and y cubed as a sum. You can factor this as x plus y, get the cube root of both of the terms. And the second factor, you'll have to do a bit of memorization. This is x squared minus xy plus y squared. Similarly, you can also factor a difference of two cubes, x cubed minus y cubed, as x minus y times x squared plus xy plus y squared. So you will notice that the first binomial will have the same sign as the original polynomial, while on the second term of the second polynomial, it will be the opposite of your original polynomial. So as an example, if you have 8x to the 6th minus y to the 9th, is this a perfect cube? So again, to check, the numerical coefficients must be perfect cubes. So 8 is a perfect cube, and -1 is a perfect cube. And for the exponents, this time, since we want them to be perfect cubes, they have to be multiples of 3. So 6 is a multiple of 3 and 9 is a multiple of 3. We now look for the factors of this polynomial. So 8x to the 6, we can write that as 2x squared cubed, while y to the 9th you can write as y cubed cubed. So this is a difference of 2 cubes. We can write it as 2x squared minus y. Same as with the original polynomial, they both apply the minus. And for the second term, we square 2x squared opposite plus 2x squared times y cubed and plus y cubed squared. So simplifying that, you will have 2x squared minus y times 4x to the 4th plus 2x squared y cubed plus y to the 6th. Okay. And as one final example, if we have 27y to the 12th plus 8. So this is a sum of 2 cubes. We can write this as 3y to the 4th cube plus 2 cube. And just apply the formula for the sum of 2 cubes. This will be 3y to the 4th plus 2 times 3y to the 4th squared minus 3y to the 4th times 2 plus 2 squared. And simplifying, you will have 3y to the 4th plus 2 times 9y to the 8th minus 6y to the 4th plus 4. Okay. Now the next type of factoring is the factoring of quadratic trinomials. So quadratic trinomials will be discussed in our next video. In that video, we will also discuss factoring by grouping, and factoring to produce the difference of two squares, as well as other ways we can factor polynomials. So thank you for watching, and don't forget to click subscribe. Thank you.